I'm Reema KB, Assistant Professor, Department of Physics, Maharani Science College for Women, Mysore. Let's discuss regarding the surface tension under paper titled Mechanics, Properties of Matter and Electrostatics. Surface tension. Under surface tension, let's study the basic concepts: pressure inside curved liquid surfaces with examples. Learning objective. Students learn the basic concepts of surface tension. Factors affecting surface tension. Analyze the types of force experienced by a static liquid and study the relation between the pressure and surface tension of a liquid under equilibrium. Session outcomes. Students appreciate the basic concepts of surface tension and obtain an equation relating pressure P and surface tension T. Basic concepts 1. Solid, liquid and gaseous states, intermolecular attraction, adhesive force, cohesive force, surface tension and surface energy, angle of contact. Basic concepts 2. Factors affecting surface tension. These are the factors which affect the surface tension: presence of impurity or dissolved substance, nature of contamination, degree of contamination, depends on temperature theta. That is, surface tension is equal to A into 1 minus theta divided by theta C, where theta C is equal to surface tension at theta is equal to 0. Normally, surface tension is inversely proportional to temperature theta. Pressure inside a liquid. A liquid experiences two forces. One is force due to hydrostatic pressure. This tends to expand the liquid. The second one is force due to surface tension, and this tends to hold the liquid together. Excess pressure inside a liquid. A liquid remains at rest and its free surface is flat when the force due to hydrostatic pressure is equal to force due to surface tension. Curved surface results from excess of pressure inside. Excess pressure is related to surface tension. To blow up a liquid in equilibrium, work has to be done or an extra pressure has to be applied against the surface tension. This work is stored as additional surface energy. Excess of pressure is also called as Laplace pressure, denoted by letter P. Excess pressure on a curved liquid surface. Considerations 1. Imagine a pure liquid drop having a curved surface with a surface tension T at a constant temperature. Consider an area A on its surface having length x with radius r1 and breadth y with radius r2. Let this liquid is slightly blown up with a pressure P so that its surface is displaced by a small distance dz. Its surface area slightly increases by dA. Original area is expressed as x into y. Therefore, new area is x plus dx into y plus dy. So that dA is equal to x plus dx into y plus dy minus xy, which implies dA is approximately equal to x into dy plus y into dx. Energy spent to do this work is force into displacement. which is expressed as P into xy times dz. Surface energy stored is expressed as T into dA, which is equal to T times x into dy plus y into dx. From the law of conservation of energy, P into xy dz is equal to T into x dy plus y dx. So, pressure P is expressed as P is equal to T times 1 over y into dy by dz plus 1 over x times dy by dz. Liquid drops are generally curved in nature. So, we need to express P as a function of radial terms rather than length terms, that is x and y. Let side x has a radius r1, so dx tends to dr1. Similarly, side y has a radius r2, so dy tends to dr2. For differentially small values, we can write dr1 is equal to dr2 is equal to dz. Under this situation, we have dx is equal to dy is equal to dz. So that equation 1 reduces to the form P is equal to T times 1 over R1 plus 1 over R2. This is the general relationship between P and T in radial terms. This is referred to as Young-Laplace equation. Equation 2 implies that excess of pressure is directly proportional to surface tension T. Depending on the shape of the liquid surface, this equation takes different forms. For a spherical surface, R1 is equal to R2, which is equal to R. Then equation 3 takes the form P is equal to T times 1 over R1 plus 1 over R2. This implies pressure P is equal to 2T by R. For a spherical bubble, P is equal to 4T by R. Because the bubble carries two surfaces, that is the inner and the outer surface. Likewise, for a cylindrical surface, R1 is equal to R and R2 is equal to infinity. Then equation 3 takes the form P is equal to T by R. And for a cylindrical bubble, P is equal to 2T by R. Because the bubble carries two surfaces, inner and the outer. Let's go for the multiple choice questions. The SI unit of surface tension is, you have four options here: joule per meter, Newton per meter, Newton meter and Newton per meter square. Second question goes like this. The angle of contact of mercury glass surface is 0 degree, option B 8 degree, option C 90 degree, option D 135 degree. The third question is the excess pressure inside a spherical liquid drop of radius r and surface tension T is A T by R, option B 2T by R, option C 3T by R and option D is 4T by R. Fourth question is, two spherical soap bubbles have radii in the ratio 2:1. The ratio of excess pressure inside them is A 1:2, B 2:1, C 1:4 and D 4:1. These are the answers to the MCQs that I had given. References: College Physics Volume 1, Mechanics, Oscillations and Properties of Matter by J.C. Upadhyaya, Himalaya Publishing House. Thank you.